Okay, this is called a complex rational function, or rational expression, because we're trying to simplify this whole thing. I'm going to work on just the big numerator first. I call this the big numerator, and then I'll work on the big denominator second. We got to treat them as own separate problems to begin with. So I'm going to start with finding the common denominator here of a and a squared, because unless I find a common denominator, I can't subtract the fractions. So my common denominator then is going to be a squared, which means now I need to ask for my first fraction, look at the ultimate denominator. What did I times the a by to become the new denominator of a squared? I had to times it by an a, which means I need to times the numerator by that same thing. So this is going to be a 7a on top. And then we have the minus sign here. And then the second fraction already had a denominator of a squared. We kept it as an a squared, so the numerator doesn't need to change at all. It's just going to be a 3. Now, as long as this is totally simplified, we're done with that step, which it is 7a minus 3 over a squared. It can't be simplified anymore, so we are done. Then we have this big fraction sign. I'll try to make it a little bolder so you can tell that that's the big fraction sign. Now let's work on the big denominator down here. Let's get the common denominator for a cubed, and a would be a cubed. And we have to ask ourselves, what did the old one look like compared to the new denominator? And they didn't change. A cubed stayed an a cubed, so the 6 can just stay a 6. The second one, a, it became an a cubed, which means it had to be multiplied by an a squared. Whatever you multiply the bottom by, you have to multiply the top by. So we're going to multiply 5 by an a squared as well. And as long as that's fully simplified, then we're done. At this step, this is what I call, I'm going to grab this because I have called it before in class, keep it, change it, flip it. That's this step right here, because we are ready to keep the first fraction the same, so that'll be 7a minus 3 over a squared. Change the divide sign, this fraction sign, to a times, that's the change it part, and flip this one over. So we have a cubed on top now. We have 6 plus 5a squared on bottom. So we can cancel some things here. I'm going to put parentheses around the factors so you know what can cancel and what can't. You can't cancel individual a's right in this part because it's connected to the 7 and we have a subtract 3. So we either have to cancel the whole 7a minus 3 or none of that at all. And the whole 6 plus 5a squared or none of it at all. But these a squareds and a cubed, you know, a cubed is like a times a times a, and a squared is a times a. Sorry, a little messy. But we can actually cancel 2 of those with 2 of these, leaving only one a on top. We still have a leftover a. So to finalize that, we could write that leftover a here. 7a minus 3 is still there. All over 6 plus 5a squared. That could be a final answer, or you could distribute that in. Another final answer could be 7a squared minus 3a over 6 plus 5a squared. And that would be another final answer.